The Explorer-1 space test, which has been going through space for more than 40 years, has made a significant declaration during its mission. Past its initial mission, it has surpassed all expectations. It was expected to endure just 5 years. Now, Explorer-1 has identified the presence of 300 unknown objects traveling through space. This revelation has completely changed our understanding, as these objects have been identified as plasmas from giant star blasts that happened a long time ago. Join us on this journey through the universe to find out what these objects, discovered by Explorer-1, are about. Unlike in earlier years, when we could only analyze data within our solar system, thanks to the advancements provided by Explorer, we now have access to data beyond it. In August 2012, Explorer-1 officially marked the boundaries of the solar system by crossing the heliopause. However, this achievement was not easy. As the test moved away from the sun, the amount of sunlight available to power instruments and systems significantly decreased. The spacecraft's power is generated primarily from 3 radioisotope thermoelectric generators, which convert the heat generated by the natural decay of plutonium-238 into electricity. As the heat output of these generators has decreased over time, the available power has also decreased, affecting the operation of several onboard systems, including scientific instruments, data transmission, and communication. To conserve energy, non-essential systems and instruments have been disabled or put in a dormant state. Even in its current state, Explorer-1 remains very significant. However, the great distance between Explorer-1 and Earth presents a significant challenge to maintaining effective communication. As the spacecraft wanders into interstellar space, Explorer-1's signal strength has weakened. It takes more than 21 hours for signals to travel from Explorer to Earth. The weak signal, combined with interference from background noise, makes it difficult to send and receive data. Additionally, the temperature change from the heliosphere to interstellar space exposes Explorer-1 to different thermal conditions. In the heliosheath, the spacecraft was closer to the sun and experienced high temperatures, while after entering interstellar space, it faces extremely low temperatures. Explorer-1 is equipped with dust detectors specifically designed to measure the presence of interstellar dust in deep space. However, communication with Explorer-1 has become more difficult due to the limited resources of NASA's global antenna system required to receive mission signals. This has resulted in fewer communication opportunities than there used to be. Despite this, a fascinating discovery recently emerged amidst the data stream. Explorer-1 detected an intriguing anomaly, the presence of 300 unknown objects passing through interstellar space. This discovery has puzzled scientists worldwide as it challenges our understanding of the universe. Are these objects remnants of ancient celestial bodies floating by, relics of distant star systems, or the presence of previously unknown phenomena? Although the data transmitted by Explorer can usually be easily deciphered, in this case the information was encrypted, raising many questions but providing few answers. Most peculiar of all, however, is that despite the unusual nature of the data, Explorer-1 appeared to be operating smoothly. Its communication link with Earth remained intact, and the signal remained strong, allowing critical information to reach NASA without issue. Interestingly, none of the spacecraft's protection systems were activated. There was no immediate indication of danger, ruling out a potential attack. So what could be causing the telemetry data to appear scrambled or inaccurate? Could it be the result of interference from cosmic phenomena such as radiation or high-energy particles? Or is it possible that we are dealing with a completely unknown phenomenon that defies our understanding of space? The only way to get certainty was to conduct a thorough investigation of a wide range of possibilities. The NASA research team thoroughly examined the systems, considering the impact of cosmic radiation on the electronics and the likelihood of temperature fluctuations affecting their sensitive instruments. It is possible that something was happening just before Explorer entered the heliosphere and that natural changes in its path would cause issues in data transmission. However, Explorer-1 was not precisely where these natural changes were strong enough to cause those problems, so that didn't seem to be the answer. The team also investigated the complexities of Explorer-1's communication systems, exploring possible distortions caused by cosmic noise, interference, or even subtle changes in its trajectory. The search for answers led to a meticulous examination of all these potential factors. The spacecraft systems were scrutinized by considering the impact of cosmic radiation on electronic components and the possibility of temperature fluctuations affecting its sensitive instruments. However, while it might seem like a simple task of checking boxes on a list, in reality, there was a lot of work to be done. Therefore, this investigation was not immediate but extended over several years. The team used advanced data processing techniques, innovative algorithms, and ran simulations of various scenarios to identify the root cause of the unexpected anomalies. At the time, this was the only method to determine what was causing the problems. All that work was not in vain. After years of receiving encrypted data from the spacecraft, scientists and engineers were finally able to restore clarity and reliability to the information coming from the far reaches of interstellar space. The cause of the problem was traced back to Explorer 1's attitude determination and control system, specifically an onboard computer that was supposed to be dormant. Surprisingly, it was discovered that the system had started using the computer despite it not being operational for many years, leading to the corruption of the transmitted data. However, the rest of the spacecraft remained functional and continued to gather data. Specialists acted quickly and sent a command to Explorer 1 instructing the system to switch to the correct computer to send the telemetry data. Although the solution was low risk, it required a great deal of patience due to the significant delay caused by the distance between Earth and Explorer 1. Radio signals take nearly 22 hours to travel to and from the spacecraft, so the troubleshooting process required careful coordination. However, there was only one issue to consider. Explorer 1 had been built many years ago and had been performing remarkably up to that point. Therefore, finding a solution to current problems was a significant challenge. It was essential for them to review several manuals from the 1970s, and that is exactly what they did. After careful examination, they found a simple solution to the problem by restoring the system responsible for data transmission. In this way, they managed to fix the issue without affecting any other part of the spacecraft. The experience and dedication of the engineering team played a significant role in restoring clarity to Explorer 1's communications. Their efforts highlighted the importance of utilizing past knowledge and combining it with current technology to address the challenges of space exploration. Engineers suspect the deviation in the use of the non-functional computer by Explorer 1 was triggered by a faulty command received from another onboard system. This hypothesis suggests a simple issue in the spacecraft's intricate computer network. Mission managers remain cautiously optimistic and stress that this incident does not pose a threat to the long-term well-being of Explorer 1. The spacecraft corrected the error and continued with its mission shortly after the correct computers came back online. The Explorer 1 space test stands as a testament to human creativity and the quest for knowledge beyond our local cosmic neighborhood. Launched in 1977, Explorer 1 was part of NASA's ambitious mission to explore the outer planets of our solar system. However, its journey didn't end there. What began as a mission to study Jupiter, Saturn, and their moons evolved into an odyssey that would take Explorer 1 far beyond the boundaries of our solar system. Explorer 1's longevity and resilience have exceeded all expectations. Initially designed for a mission duration of 5 years, it has now been operational for more than 40 years. This remarkable achievement is largely due to the spacecraft's robust design and the dedication of the teams who have managed its mission over the years. One of Explorer 1's most significant achievements came in August 2012 when it crossed the heliopause, officially entering interstellar space. This boundary marked where the influence of our solar wind gives way to the interstellar medium. Crossing this boundary provided scientists with unprecedented insights into the dynamics of our solar system's outer reaches and the environment of interstellar space. The journey into interstellar space has not been without challenges. As Explorer 1 travels farther from the Sun, the intensity of sunlight available to power its instruments decreases. The spacecraft relies on 3 radioisotope thermoelectric generators, RTGs, to convert heat from the natural decay of plutonium-238 into electricity. Over time, the declining heat output from these RTGs has reduced the spacecraft's power supply, affecting its operational capabilities. To optimize power usage, non-essential systems and instruments have been either disabled or put in a dormant state. This essential management ensures that Explorer 1 can continue its mission while conserving energy for critical scientific observations and data transmission back to Earth. Communication with Explorer 1 presents another formidable challenge. As the spacecraft ventures further into interstellar space, the distance between it and Earth increases, affecting signal strength and transmission reliability. Currently, it takes over 21 hours for signals traveling at the speed of light to reach Explorer 1 and return to Earth. This delay requires careful planning and coordination for data retrieval and spacecraft commands. Despite these challenges, Explorer 1 continues to provide valuable scientific data. One of its most intriguing discoveries came when it detected the presence of 300 unknown objects traveling through interstellar space. These objects, identified as plasmas from ancient supernova blasts, have raised new questions about the composition and distribution of matter beyond our solar system. The discovery of these interstellar objects underscores the importance of Explorer 1's extended mission. By venturing beyond the boundaries of our solar system, Explorer 1 has expanded our understanding of the universe's vastness and complexity. It has enabled scientists to study phenomena that were previously out of reach, offering glimpses into the distant past of our galaxy and beyond. The spacecraft's instruments, including dust detectors designed to measure interstellar dust density, continue to operate despite the challenges posed by extreme temperatures and cosmic radiation. These instruments provide critical data that contribute to our understanding of the interstellar environment and its potential.